Okay, we're going to solve quadratic equations graphically and also algebraically today. You will need your notes, a pen, and a cat. You will also need a baby. Get out your favorite romantic candles and get ready to do some math. Get out your favorite pen and get ready to be amazed. I think we already know a lot about the zeros in general. We looked at them in the last unit. We know that they're the X-Intercepts of Parabolas. In this specific example, you can see that the parabola crosses the x-axis at -1 and 2. Thank goodness for eyes. Flipping the page over, we kind of know from when we did the discriminant that there's basically three things that can happen. You can have one real solution, two real solutions, or no solutions. Remember that for the discriminant, that's the formula b squared minus 4ac. If there's one solution, then the discriminant equals 0. If there's two solutions, then the discriminant is greater than 0, and for no solutions, really sad, discriminant is less than 0. Moving along, we get to this first question, which says to solve it by graphing. We're going to do a blend today, so if you're solving by graphing, then it's kind of the luck of the draw. So that means you can make a table of values, get lucky, and hopefully you can find the x-intercepts just by, guessing. So I'm going to maybe try 1, 2, 3, 4. For my x values, I'm going to be plugging it into this equation. So when x is 1, I'm going to be getting for my y value, and see if I can do this quick on my head, I think I'm going to be getting 15. I'm going to try to fill in the other ones here. So I'm just plugging it into this equation. So for 2, I'm going to get 4 plus 12 plus 8, so I'm going to get 24. I don't think this is ever going to work. Yeah, okay, so I don't think that's going to work. I see these getting bigger. Kind of getting a little frustrated here, so I'm going to make these maybe negative. So I'm going to try -1 and -2. When I plug in -1, I'm going to be getting, I guess, 1, subtract 6, so I'm going to get -5 plus 8, I'm going to get positive 3. When I plug in 2, I'm going to get 4 minus 12 plus 8 equals 0. So it looks like I'm going to get 12 minus 12. So finally I found one of my x-intercepts. So just a reminder, when the y value is 0, we know that we have found an x-intercept. Okay, so I'm back. I kind of got a little impatient. I went ahead and did the work for -3 and -4. So here I got y equals 0, so I know that -4 is an x-intercept. When I plugged in -3, I got -1. So just ignore this suspicious blotch that must have been the photocopier on my page there. So I went ahead and I graphed -2 and -4, which are my x-intercepts. If I look back at my equation, so when I have it set equal to 0, I see that my a term is positive, so I am expecting this to open up. So where the table of values can help you graph these things is your vertex is always going to be somewhere in between your two x-intercepts. In fact, it's always going to be exactly in between them. So if I got -2 and -4 here, I know that my vertex should probably happen at x equal -3. So I already did that point, and I got -1 for y. I'm going to go ahead and plot that. That is enough info for me to draw this parabola. So because I know it's opening up, I can go ahead and I can do this. I should probably, it's a good habit to figure out all your intercepts, so I should go ahead and find the y-intercept. So that is when x is equal to 0. So if I go ahead and I plug that into my equation, I'm going to get these two terms with the x's disappearing because they're going to equal 0, and I'm just going to get 8. So I will be just getting y equals 8. So I'm going to count that up over here. I'm going to write that y equals 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, I guess 8. And that will be more than enough info for me to draw that graph. And just completely ignore the fact that I missed that point. This is tricky. I'm trying to hold my phone with one hand, got my pencil, my pen in the other, and it's a very nice one, as you can see. It is in Atlantis, which is actually a underwater city, so that's very fancy. Moving along to another question here. Okay, so for this question, I would like you guys to use Wolfram Alpha. So Wolfram Alpha. You guys all have computers in front of you, so I hope you can work together to figure it out. If you just type in exactly this and say graph, then you can visually see the x-intercepts. We'll just kind of leave this out. We don't really care about this, so don't worry about that. You can calculate the discriminant, so you're just going to kind of verify, maybe before you go graph it, just how many roots you're expecting, so you can kind of predict how many roots you're going to get. So I'll be checking this one later. So I'd like to do another one, and I'd sort of like to speed things up a little bit. So the technique that I'd like to use on these ones, getting a little out of focus there. What's going on here? That's better. So it is giving us a hint that there's one real solution. The technique that I'd like to do is I'd like you to factor. So hooray, factoring comes back. I'd like you to factor and just figure out your x-intercepts, and then maybe we can find our vertex using the table. Okay, so remember that as far as where the vertex is, it is always in between the x-intercepts. Exactly in between. So let's go ahead and do this like it was, the last unit. So we're going to move everything over to the same side. So we're going to add 9 to both sides. We're now set equal to 0. So I'm looking for two numbers that multiply to 9 and add up to -6. So those two numbers are going to be -3 and -3. Turns out this is actually, voila, ooh, I like that. This is actually a perfect square trinomial. So x minus 3 and x minus 3. Okay, I could write it with the squared. When you solve, use the zero product property. So those two brackets equal to 0. You're just going to get x equals 3. So I guess this is kind of a weird one. So when y is 0, x is 3. So we're going to go 1, 2, 3. I'm going to need a couple more points if I'm going to graph. So I'm just going to recommend let's find the y-intercept. So we're going to plug in when x is 0. So just going back to say this equation here, when you plug in x equals 0, it's really easy to see you're going to get y equal 9. So that's 0 and 9, which I believe is right up here. I'm going to check 1, 2, 3, 4, 5, 6, 7. What's going on here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll just kind of extend our graph a little bit. So there's that. I'm going to do my best to get a nice curve there, much better than before. Just to get another point over here, you can kind of plug in what you like, x equals 4. Just something that's bigger than this, just so I can kind of see what the curve looks like over here. So when I plug in 4, I'm going to get 16 minus 24. Okay, follow me here. So I'm going to be at -8 plus 9. I'm going to get +1. So that's 4 and 1. Kind of what I was expecting. So it'd be nice to get a few more points, but not necessary. So there it is. We're just sketching it. Okay, so it doesn't need to be perfect, but you do need a minimum, absolute minimum 3 points to graph a parabola. Okay, so what are these points? Well, you need the X-intercepts. The Y-intercept is really nice, and you definitely need the vertex. Okay, let's do another. I'm not going to give you guys a fancy transition. Ooh, look at this counter. Very nice. This one has no real solution, so this one might be worth doing a little bit later. So I'm actually going to skip that one and do the one underneath it and then go back. Okay, so for this one, again, I'm going to use that method of I'm going to factor to figure out my x-intercepts and then see if I can figure out where my vertex would be. Going to be looking for two numbers that multiply to +6 and add up to -6. I don't think you're ever going to find those two numbers. Definitely seems a little odd, so I have a couple options. Well, I shouldn't say a couple options. Pretty much I'm going to complete the square on this one, so that's a blast from the past. They are giving us a hint, and they're giving us the axis of symmetry at x = 3, so it doesn't have anything to do with completing the square, but we kind of know where the vertex is. So I'm kind of expecting my x-intercepts to be on either side of this line, and I'm expecting this thing to open up. So let's go ahead and complete the square. So we'll just do that down here. So you may have to review your notes from the last unit, but your first step is moving that 6 over there. So I'm going to get a -6. You're going to take that b term to find k. So you're going to do this. You're going to take that b term, divide by 2, square it. So you're going to get, I do believe, +9. So you're going to add 9 to both sides. This is now a perfect square trinomial. So I'm going to grab this, square root it, you get x. Grab the negative sign, square root the 9, you get 3. Write it as a binomial squared, and that is going to be equal to +3, square root both sides. So you're going to get the radicand out. You're going to get plus or minus square root 3. Going to move the 3 over to the other side. So we kind of get this ugly looking thing. I'm going to just plug this into my calculator. Okay, so I went ahead and calculated these two roots. You get 1.3 and 4.7. They are saying the axis of symmetry is 3, so when you graph these two roots, there's about 1.3, there's about 4.7. You know that your vertex is going to be exactly in between here at x = 3. If you look at the distance from the vertex, it's actually 1.7 units on each side. So if you go back 1.7 units, you'll be at 1.3. If you go forward 1.7 units from there, you'll be at 4.7. So that all seems symmetrical. When you calculate x = 3 and you plug it into this equation, you're going to get 9 minus 18 plus 6. So it looks like we're going to get, -9 plus 6, we're going to get -3 for our y value, which would be right there. That is probably enough information. Doesn't hurt to calculate the y-intercept, so that is where x = 0, and you will get 6. 1, 2, 3, 4, 5, 6. Now that we have that, we pretty much have all the information we need to graph this parabola. And there we go. Taking a look at this one, the one that has no real solution, you can see that quite easily just by trying to solve this equation. You're going to get, at some point when you solve for x, you're going to get a negative square root. I can go ahead, I can do it over here. So move that over there, you're going to get that. You're going to divide both sides by -3. So at this point, when I try to square root both sides, I can't square root a negative number. So that means I have no roots. So in that case, the only thing we can do is a table of values. In general, some good points to pick would be -2 to 2. When you go ahead and you plug in all those numbers into the equation, you will get this. So don't be worried if you're seeing duplicates in your y values. It's actually good, because remember, parabolas are symmetrical, so I'm noticing that the x values are different, the y values are the same, and I'm seeing that a couple times. At this point you can graph everything. I'm just going to start, I guess I'm going to start on -1, because this 13, that's kind of off my graph. I'm going to hope that I have enough information. When I have this thing set equal to 0, my a value is -3, so I am expecting this thing to open down. So I'm going to see what I get. When I go -1 and -4, I'll be down here. When I do 0, I'll be here, and then -1 for y. When I go 1 and -4, I'll be over here. So it turns out that that's actually enough information to graph this thing. So I can see the axis of symmetry. It's going through the vertex. So the axis of symmetry is 0. More specifically, I should really say x equals 0. And that's it. You got a graph. This last question I will let you guys think about. There is a solution online. See if it makes any sense, and we can talk about it tomorrow. Otherwise, I expect you guys to do the practice problems. Okay, good luck, and this has been another amazing math video.